Welcome back. We're going to start with an overview of identifying point and non-point sources of nutrients in Colorado. Again, this video tutorial and guide are being developed to support designated planning agencies in their work on developing their 208 plans for their respective regions. Today, we're going to be covering the CLEAN dashboard, or the CLEAN Nutrient Decision Support System. It goes by a few names. CLEAN is the Center for the Comprehensive, Optimal, and Effective Abatement of Nutrients. It was a EPA STAR grant that did a lot of research into nutrient abatement in urban areas and non-urban areas. This tool is going to really help out with identifying the different wastewater treatment plants in your area, the location and metadata around the agricultural sector, as well as some others. That's going to have a whole section on summarizing nutrient source loads, and then changes in magnitude and relative contribution over time based on projection and what if scenario planning. So like, what if more sprinkler irrigation is put in? What if a new treatment plant comes online? What if an existing treatment plant reduces their output or increases their output? And those sort of BMPs and what if scenarios. So today we're going to be taking a look at our ERAMS dashboard. ERAMS is a little bit different than the Katina setup, so you'll have to log into your account. You can set up an account for free if you don't have one. Once you log in, you're going to be taken to your account project page. Here you'll find every project that you have. You can create a project with type of clean nutrient dashboard. That's going to give you access to the CLEAN tool. If you already have one, feel free to navigate to it. I already have one right here that I'm going to go ahead and load. So the CLEAN tool is going to look and feel very similar to a lot of our other tools. It's going to be a map interface on the main content. It's going to be a left panel that has a lot of other content for how to interact with the map, how to interact with the tool, how to set your inputs, your BMPs that you want to analyze, all those fun pieces. To start off with, you won't have anything in your current scenario dropdown. I do because this is an existing scenario. So what you're going to want to do is you're going to want to define your area of interest. There's a number of ways to do that. You can do that by copying an existing scenario. You can do that by drawing a point or a line or a polygon or a rectangle on the map that you can digitize. You can also do it by uploading your own watershed boundary, right? If I want to upload a shapefile from ArcMap, I can upload that here. You can also look for a stream segment, right? So CDPHE maintains WBIDs and AUIDs, segments and portions across Colorado. If you know the ID number for that segment, you can go search for it, and we have a database of watersheds associated with those stream segments, and that'll auto go fetch that watershed for you. So you can use that as the extent of your interest. You can also do things like within an existing layer that you've uploaded, right? I've got a few layers that are uploaded here that I could choose between, or you could do something simple like I want a county. I want Larimer County around the city of Fort Collins, and I want to know what sort of nutrient sources are in Larimer County. Or you could say I'm interested in this sub-watershed that's a HUC 8, it's a HUC 10, it's a HUC 12, right? The bigger the area you assess, the longer it's going to take, but you can do any of these in the CLEAN dashboard. So if I wanted to go say pick the HUC 12s in and around Fort Collins, I could say I want the HUC 12 right here at the Cache Lapooter. It's going to be this little area that's already digitized. It's just going to show it a second time because I selected it. I can give it a name. If I want to do that, I can go back to how I want to define my watershed or which one I want to go look at. So if I go ahead and pick one of those, it's going to advance me to the next step of the tool. You'll notice that there's two parts here. This is, do I want to analyze current conditions? Do I want to analyze future conditions? Current conditions use base climate data from PRISM, population data from US Census, and land use from an LCD. Future projections allow you to customize the population land use impacts. So you can basically digitize an area on your on the map and then say this area is going to be a subdivision. This one's going to be a mall. This one's going to be we're going to reinvigorate downtown, and we're going to have a denser urban area than the sprawl that used to be here. That used to be a neighborhood. Now it's going to be a skyscraper high-rise kind of thing. So you can pick which one of those is relevant to yours. If you pick the custom, you're going to get this extra future changes pop up that's in the center of my screen. You can delete any of the subunits in here that you generate, they're going to be auto numbered, and you can go look at all their properties, right? So you can look at this is a 6.6 square mile subunit that has an average annual precipitation. It's got a base population. It's currently an open land use type. It's got no imperviousness. And then I can pick for my area, when will this develop, right? If I want to say there's going to be a subdivision in the next 5 years, I can say it's going to be built in the next 5 years, and then say, okay, what's the population that's going to be impacted? This is where that crossover with this, or hook up with the state demographers data set goes in. So based on what fraction of the county you're in, is going to try and estimate the change in population for that area for you, rather than just you having to do it yourself. You can override any of these numbers. You can say this population is going to be 200 people or 600 people. Or you can say things like it's going to grow by 3%, or if I have 3 people per house, you can back calculate how many houses you're going to have out of these. So if I have 200 houses at 3 people, I'll have 600 people, right? So you can mess with whichever one of those metrics is more relevant or more useful or more familiar with you for your population projections. You can also then classify its land use type, right? Is this going to be an open space area? Is this going to be an urban area that's getting going to be spread out? Is this going to be a more medium intensity? Is this going to be a city downtown that's expanding? And then it's associated imperviousness and its associated base stormwater runoff numbers. These are pre-populated from the Reg 85 data analysis. So that tries to summarize your existing runoff quality from those urban areas. So if I were to change this to say a medium intensity, you'll notice that my nitrogen number changes, my phosphorus number changes. Those are based on that Reg 85 data analysis project for typical runoff from those urban classifications. Once you're happy with those for your area, you can go ahead and save them. It'll pop up that says you saved it. You can keep moving on. If you want to draw more, you can draw any more of those custom subunits. You can do a polygon, you can do a rectangle, you can do known boundaries within your area, right? So if I wanted to examine Larimer County and every sub-watershed within Larimer County, that'd be one way I could do it. Once you're happy with your land use and your climate, you can go to the next step, and this really defines the different sectors of nutrient sources across the state. This is your wastewater treatment plants, this is your stormwater, this is your cities, this is your agriculture, and all of those kind of things. You'll notice that it tries to load a summary of layers in and around your area of interest. I'm going to turn these off and go one by one to show you what they are. If I want to look at that first one, it's just going to show me wastewater treatment plants, right? I can open my legend and see that these are colorized by what type of treatment process is at that facility. It's a BNR process, a biological nutrient removal. And these icons are scaled by their discharge size, right? So I got a couple. This one looks a little bit bigger than that one based on their output size. If I want to look at municipal extents, right, this is just city boundaries, right? How big is the city of Fort Collins? How big is the town of LaPorte? You can just see how those overlap on your area of interest. They're opaque, so you can see the base layer behind it. You can look at the permanent MS4 systems, right? So these are the urbanized areas and the urban clusters nearby. So you can see the city of Fort Collins in this urban cluster, the red boundary, and the city of Fort Collins in blue. You can see those extents on that map too. Please note that the Clean Nutrient Dashboard is not recommended for analyzing stormwater. There is a separate DPA guide and a separate video tutorial dedicated to using the classic tool in our tool portfolio for analyzing BMPs, like cycle assessment costs, and loading water quality impacts from stormwater systems. The Clean Dashboard has a different methodology that's a lot older and simpler. Classic is a lot more advanced. You can look at an estimate of dryland agriculture, right? You can look at the different land use types that are in there, as far as, is this a grass pasture? Is this alfalfa that was grown there? You can also look at the irrigated fields that exist within your area of interest. And again, you can look at the crop type associated with those. Do they grow corn? Do they grow barley? Do they grow beans? Based on those field boundaries. From there, you get to specify basically what you're going to analyze, the what if. Do I want to look at current conditions? Do I want to look at some future scenario where I know another wastewater treatment plant is going to come online, or 5 years from now, they're going to cut their output by 10% based on water reclamation or something like that. So you can build all of those what ifs here. Again, we're not going to go into the stormwater side because there's a better dedicated tool for that. We're just going to focus on wastewater treatment plants, and we're going to focus on the agricultural side. Under wastewater treatment plants, you got a few different options. You can look at current conditions. You can look at what if I discharged at my current volume, but right at the limit of what regulations have. That's your maximum allowable nutrient concentration. There's another what if of what is your permitted capacity versus the maximum allowed by discharge regulations. You can also look at things like what if I have a user specified reduction or alternately increase, right? What if this facility is going to get 5% bigger in the next 10 years, right? What's that going to do to the picture of nutrients in the watershed? Or what if they add a new treatment technology, right? So if I wanted to look at treatment technologies, I'm going to get a list of all the facilities that I have, and I got the ability to go in and say, okay, right now it's got a permitted capacity of 2, 23, and 6 million gallons per day, and they're a BNR process. What if I wanted to add a treatment technology? What if I wanted to add modified Ledzik-Ettinger system? What if I wanted one of those with post-aerobic digestion? What if I wanted those with a 5-stage barbitol fentanyl? You can do these what ifs. These have all been calibrated using BioWin simulations, so they're generalized and calibrated based on Colorado data. There's a few different papers in the CLEAN documentation that you can look up for those sources. Similarly, if you were to do a what if on reduction, you can look at your list of facility and say, well, this one's going to increase or decrease by 5%, and this one's going to increase by 2%, right? Because this is a reduction, you're going to want to have a negative to make it an increase. You can save those changes and do your what ifs. We're going to skip stormwater and go into agriculture. Agriculture, again, is that what if of what's going on in those fields. By default, you're going to start off with no change in irrigation and default tillage types, right? So what if I had a different tillage type? So what if I know that 20% of my fields are going to go to sprinkler drip irrigation over the next 20 years? What if I know that we're going to reduce the amount of typical conservation? We're going to do something more like a strip tillage. That's going to start coming into effect. You'll notice that these color code each other and warn you if they don't add up to 100%. So it's got some help notifications in there. And then you can look at how many of my fields split apply their fertilizer, right? Rather than doing a lump of a lot of fertilizer in one go, you can apply the same amount of fertilizer across multiple applications throughout the year, and less of that is likely to run off the fields into groundwater, less of it's likely to run off the fields into surface water. So those are the different BMPs you can look at. You can also look at some contextual data layers. This is mostly just the stream network in that area. So you can look at the different stream segments. Again, these are the stream IDs that I was talking about earlier, and your watershed boundary option. So you can look at which one of these you're analyzing, right? In Larimer County, what are the stream segments of interest? Are there monitoring sites like this one that could have historic long-term flow data or water quality data that's available to me to help supplement my analysis, and you can look at those. Once you've picked all of your inputs, you know what you want to model. I want to look at a reduction scenario. I want to look at this scenario for agriculture. What you're going to want to do is you're going to want to pick and hit the check mark next to the scenario you want to run, right? You can run multiple scenarios and compare them side by side. And then you're going to want to go down here and click the run button. That run button is going to open a little tab down here that says I'm going to run so many different scenarios, right? So there's one operation per category, right? So you need wastewater treatment plants and stormwater and irrigated ag and background and stream monitoring discharge data. Depending on the area, size of the area that you're analyzing, this is going to take a while, right? If you're doing a small watershed that's just some fraction of the city, this will take a little under a couple minutes. You're doing something the size of Larimer County, you're probably going to be waiting 5-10 minutes just because of the amount of data that sits behind there that's actually getting processed in real time. So just be patient until that counts down to the bottom. Once it's done running, you're going to get a pop-up down here that's going to give you a bar chart of what your total loads look like in your watershed, right? So I've got 1.2 million pounds of nitrogen getting generated in this watershed. I can look at my phosphorus side of it. I've got 155,000 pounds of phosphorus. I'll also get a subunit summary, right? So what happens to, I'll go back to my map and show you. Remember, I had this little user 1 area. So what happens if user 1 develops over the next 10 years? I'm going to have an increase of 400 people, remember, compared to current conditions. I'm going to have my change in imperviousness associated with turning that into an urban area. That's going to result in an increase in nitrogen and phosphorus from the wastewater treatment plants and a change in the agricultural associated with it, right? So if that's over a crop field, it'll automatically say, okay, you built a subdivision on top of where a crop field used to exist. We're going to remove that amount of crop nutrient sources from your total, so you're not getting all of that. One of the other alternatives that you can look at with wastewater treatment facilities is, what if I have a new treatment plant coming online, or what if I'm going to take one out of service, I'm going to merge, or what if I have two facilities that are going to merge their discharge, right? What if I have two nearby towns and they've grown enough that they want to consolidate their wastewater treatment plants into a single large-scale infrastructure? You can analyze that sort of question using the CLEAN dashboard under this user-specified reduction option. What you would do is you would basically say, what if my hypothetical is I have this Box Elder Sanitation District 1 and I have the City of Fort Collins 1. You'll recall that I've got a permitted capacity for one of those at 2 million gallons per day, and the other one's 23 million gallons per day. So a reasonable what if would be, what if the Box Elder Sanitation District, the little guy, the 2 million gallons per day, goes out of production? What if we completely shut that facility down, build a pipe over to the Drake water reclamation facility that the City of Fort Collins operates, and they discharge at 25 million gallons per day? That's a reasonable question to ask what that's going to look like. Especially if, for example, one of your facilities has older technology and is not quite as efficient at getting nutrient removal. So you could do something like 100% reduction on the Box Elder Sanitation District, and then you could modify the City of Fort Collins one by that corresponding difference. You got to do a little bit of math for that percent reduction, right? So if I'm going to increase from 23 million gallons per day to 25 million gallons per day, I'll throw a little calculator up and just show you. So if I'm going to increase by 2 out of the 23 that I have, that's going to be an 8.7% increase. So I'm going to want to make this a negative reduction, 8.7, right? So a negative reduction is an increase. And you can basically analyze what if the Drake facility gets proportionally bigger to absorb the Box Elder facility. And you can go ahead and save that. You can go ahead and run that, and you can see what that's going to look like from your nutrient removal picture.